Hello everyone, welcome to my video. And today I will talk about the inverse functions and their derivatives. So now let's get started. So first one, let's take a look at our contents first. That will cover the one-to-one functions, inverse functions, find the inverse and derivatives of inverse of differentiable functions. So now let's start with one-to-one function. So here we have the definition that say a function f of h is a one-to-one function on the domain D if f of h of 1 is not equal to f of h2, whenever h1 is not equal to h2 in domain. So to understand more about it clearly, let's take a look at example. We have example A, function f is equal to square root of h and the domain is from negative infinity to positive infinity. So here we just use the value of h to get the value of f of h here, which is from 1, 4, 9, 16, 25, and we get the value of f of h with 1, 2, 3, 4, 5. Then they say f of h equal to square root of h is one-to-one function since different values of h in domain give different value of f of h, as you can see right here. There's no different value of h that give the same value of f of h. Even though we add more value of h, we still get the different value of f of h. So they say it is a one-to-one function. So here let's take a look at another one. Example B, we have function y equal to x squared. Domain is the same, negative infinity to positive infinity. Right here we give the value of h and get the value of f(h) here. So let's take a look at when h equal to 2 and h equal to h equal to negative 2 and h equal to 2. These two values of h give the same value of f(h), which is equal to 4, as you can see here. And another one when h equal to negative 1 and h equal to 1, it gives the same value of f(h), which is 1 right here. So they say f of h is equal to h squared is not a one-to-one function, since some different value of h in domain give the same value of f(h) as I show in the red circle right here. So now let's take a look at another one. We have the same function, but now we present it as a graph. So how to identify the one-to-one function by looking at the graph. So here we have a function right here, graph of the function, and we have a horizontal line right here. And then let's say one-to-one function, graph meets each horizontal line at most 1. So where is the intersection point between graph and the horizontal line? It is right here, and it is only 1 here. Even there's any horizontal line, there's only one intersection point between graph and horizontal line. And now let's take a look at the not to one-to-one function. And here we have the graph, and when we compare it to each other, we can see that here we have only one intersection point between graph and horizontal line, but right here we have the intersection point right here, and another one is right here. So we say not one-to-one function, graph meets each horizontal lines more than once. So now we can conclude the horizontal line test for one-to-one functions, which is a function y equal to f of h is one-to-one if and only its graph intersects each horizontal line at most 1, as I show in the previous slide. Yes. So now let's move on to the inverse functions. Introducing inverse function. So they say a function that undoes or inverts the effects of a function f is called the inverse of s. So here is the definition. Suppose that f is a one-to-one function on the domain D with range R. The inverse function of f is defined by inverse function of b equal to a if in function a, f of a equal to b. And the domain of inverse function of f is R, and the range of inverse function of f is D. So to understand more about it, let's see the example. So example here we have a function f of h equal to cube root of 5h plus 2. And then give the value of h which is equal to 5, and then the equation will become like this. And we just solve the equation for f of 5, then we will get the value of 3. And here's another one. We just change from from f of h into y, and we keep the same equation here. But now we not give the value of h, but we solve for h. Solve the equation for h, and then we give the value of y, which is we found it in here. We just replace y by the value of 3, and then we will get the value of h, which is equal to 5. And then f of y equal to and then we just compare the equation function 1 to function 2. Then we will get that function 1 and function 2 is equal, because here f of h is equal to y, and then y equal to 3, and h here we just place 3, we get the h from 5, which is we replace 5 here, so we called it inverse function. So now let's take a look at another example. We have two functions f of h equal to h cubed and inverse function of f of h equal to cube root of h. And here we have the domain of f of h is 1, 2, 3, and the range here. And its inverse function, the domain will become the range, and range will become the domain, and just like this. So they say it is an inverse function. So here's another one. Suppose the one-to-one function y equal to f of h is given by table below. So the table value of f of h is right here, which is the value of h and the value of f of h. So its inverse function, we just change the value of h by the value of f of h that we have found, and we will get the value of f of h, which is the same as the value of h that we give previous. So they call it inverse functions. So now let's move on to the finding inverse. So the process of finding the inverse functions can be done in 2 steps. First one, interchange h and y. Second one, solve the equation y equal to f of h for h. This gives the formula is equal to inverse function of f of h, where h is expressed as a function of y. So let's take a look at the example. They want us to find the inverse of y equal to 2 over 3 times h plus 4 expressed as a function of h. So solution, we just write down the function here, and then we need to do is step 1 to chain row into h. So chain row right here, this means that we change from y to h and h into y, and then we will get a new equation right here. Then step 2, we just need to solve the equation for y. Then it will become like this, and we can say that y right here is the inverse function of f of h, which is equal to 3h minus 12 over 2. And that's all. And another one, find the inverse of y equal to h squared, h is greater or equal to 0, expressed as a function of h. So solution, the same, we just write out the equation and change the row into h. So here, y into h and h into y, and then we just solve the equation for y, which is equal to square root of h, or we can say that y is the inverse function of f of h, which is equal to square root of h. Yeah, that's all for the inverse function. Now let's continue to the derivatives of inverse of differentiable functions. So here we have a theorem that say if f has an interval I as domain and its derivative of f of h exists and is never 0 on I, then inverse function of f is differentiable at every point in its domain. The range of f, the value of derivative of inverse function of f at point B in the domain of inverse function of f is the reciprocal of the value of derivative of f at point A equal to inverse function of b. So now we can get the formula, which is the derivative of inverse function of b, of f of b, equal to 1 over derivative of f of inverse function of f of b. So now let's take a look at the example. Example 1, we have the function f of h equal to h squared. H is squared equal to 0 and its inverse is equal to square root of h that has the derivatives 2h, and the derivative of its inverse function is 1 over 2 times square root of h. So solution, we just write down the function, and it is the inverse function of it. So here we just do the derivative in the both sides of the equation, which is a derivative of y and derivative of h squared, and then we will get the value of here, and we just solve the equation to get the dh over dy, which equal to the inverse function of the derivative of inverse function of f of h, which is equal to 1 over 2 times square root of it right here, and that's the answer. So now let's take a look at another one. We have f of h equal to h to the power of 5 is the formula of function y equal to f of h. Find the inverse function of f of h and identify the domain and range of inverse function of f. As a check show that f of inverse function of f of h is equal to inverse function of f of h equal to h. So solution, step 1, we just need to find the h of 5, which is equal to y times y to the power of 1 over 5. And then we solve the equation for y, which is equal to square root of 5 root of h, and it is also equal to the inverse function of f of h. And then the domain and the range of inverse function of f will be the all real number. And now they want us to show that f of inverse function of f of h is equal to h. So here we just put the value of inverse function of f of h that we found right here. We just put right here, and then we have the value of f of h, which is right here. Then we just solve them, then we can get h. Another one is also the same. We just place the value of f of h right here, and then we solve this one, and we get the value of h. So that's all for the derivative. Now that's all for today, and I hope you guys enjoy my video and understand more about the one-to-one function, inverse function, and how to find the inverse, and how to find the derivatives of its inverse function. So that's all for today. Have a good day. Goodbye.